Hellenistic period, spanning from the death of Alexander the Great in 323 BCE to the rise of the Roman Empire in 31 BCE, was a time of remarkable intellectual achievement. This era saw the synthesis of Greek, Egyptian, Persian, and Indian cultures, fostering an environment ripe for scientific innovation. Among the prominent scientists of the Hellenistic period were Archimedes, Eratosthenes, and Hipparchus, whose groundbreaking contributions laid the foundation for various scientific disciplines, including mathematics, astronomy, geography, and mechanics. Archimedes, the genius of mechanics and mathematics. Archimedes of Syracuse, c. 287 BCE, c. 212 BCE, was a polymath who excelled in mathematics, mechanics, and engineering. His works influenced not only his contemporaries but also future generations of scientists. 1. Mathematical achievements. Archimedes made significant contributions to geometry, calculus, and numerical analysis. He developed methods to calculate areas, volumes, and surface areas of irregular shapes, which foreshadowed integral calculus. One of his most famous discoveries was the formula for the volume and surface area of a sphere, inscribed in a cylinder. Archimedes considered this his greatest achievement, and his tomb was adorned with a sphere and cylinder to honor this work. Part 2. The principle of buoyancy. Archimedes' most famous practical discovery is the principle of buoyancy, now known as Archimedes' principle. According to legend, he formulated this principle while bathing, leading to his exclamation, "Eureka!" This principle states that an object submerged in a fluid experiences an upward force equal to the weight of the displaced fluid. This discovery has been fundamental to fluid mechanics and continues to be applied in modern engineering and shipbuilding. 3. Contributions to mechanics. Archimedes is credited with numerous inventions, including the compound pulley and the Archimedean screw, used for raising water. His understanding of levers led to his famous assertion, "Give me a place to stand, and I will move the earth." He also designed war machines, such as catapults and mirrors, to focus sunlight and set enemy ships on fire, which were used to defend Syracuse from Roman attacks. 4. Influence on modern science. Archimedes' works, preserved in texts such as On the Sphere and Cylinder and the Method, provided the mathematical rigor that influenced Renaissance scientists like Galileo and Newton. His approach to solving problems using logic and experimentation laid the groundwork for the scientific method. Eratosthenes, the father of geography. Eratosthenes of Cyrene, c. 276 BCE, c. 194 BCE, was a polymath who made pioneering contributions to geography, astronomy, and mathematics. He served as the chief librarian at the Library of Alexandria, where he conducted much of his groundbreaking work. Measuring the Earth's circumference. Eratosthenes is most renowned for calculating the Earth's circumference with remarkable accuracy. He observed that on the summer solstice, the sun was directly overhead in Syene, modern-day Aswan, Egypt, while it cast a shadow in Alexandria. By measuring the angle of the shadow and the distance between the two cities, he estimated the Earth's circumference to be about 40,000 kilometers, astonishingly close to modern measurements. Parameter 2. Mapping and cartography. Eratosthenes is credited with creating one of the earliest maps of the known world, incorporating parallels and meridians to divide the Earth into a grid system. This innovation was a precursor to modern cartography and helped establish geography as a scientific discipline. 3. The sieve of Eratosthenes. In mathematics, Eratosthenes developed an algorithm for identifying prime numbers known as the sieve of Eratosthenes. This method systematically eliminates non-prime numbers from a list, making it a foundational tool in number theory that remains relevant today. Pair 4. Contributions to chronology. Eratosthenes attempted to establish a scientific chronology of events in Greek history. By cross-referencing various historical records, he provided a systematic timeline, which contributed to the field of historical analysis. Eratosthenes' innovative methods and interdisciplinary approach set a standard for future scientists. His work demonstrated how mathematics and observation could be combined to understand natural phenomena. His contributions to geography influenced later figures such as Ptolemy, and his prime number sieve remains a staple in modern mathematics. Hipparchus, the father of astronomy. Hipparchus of Nicaea, c. 190 BCE, c. 120 BCE, is often regarded as the greatest astronomer of antiquity. His systematic approach to celestial observation and his development of astronomical models profoundly influenced the study of the heavens. 1. Cataloging the stars. One of Hipparchus's most significant achievements was compiling the first known star catalog. He recorded the positions and brightness of approximately 850 stars, dividing them into 6 magnitudes based on their apparent brightness. This classification system is still used in modern astronomy. 2. Discovering the precession of the equinoxes. Hipparchus discovered the phenomenon of the precession of the equinoxes, the gradual shift in the orientation of the Earth's axis. By comparing his star catalog with earlier observations, he determined that the positions of stars relative to the equinoxes changed over time. This discovery was a milestone in understanding the long-term dynamics of the Earth's motion. Mach 3. Contributions to trigonometry. Hipparchus made pioneering contributions to trigonometry, particularly the development of a chord table, which facilitated the calculation of angles and distances in astronomy. His work laid the foundation for modern trigonometric concepts such as sine and cosine. 4. Developing astronomical models. Hipparchus refined the geocentric model of the universe, proposing that the apparent motion of the sun and moon could be explained using combinations of circular orbits, or epicycles. Although later replaced by the heliocentric model, his work represented a significant step in the mathematical modeling of celestial movements. 5. Predicting solar and lunar eclipses. Using his mathematical models, Hipparchus was able to predict solar and lunar eclipses with greater accuracy than his predecessors. His methods demonstrated the power of combining observation with mathematical analysis. Hipparchus's contributions laid the groundwork for the later achievements of Ptolemy, whose Almagest built upon Hipparchus models. His star catalog and discoveries in celestial mechanics remain landmarks in the history of astronomy. Interdisciplinary impact and legacy. The contributions of Archimedes, Eratosthenes, and Hipparchus exemplify the intellectual vibrancy of the Hellenistic period. Their work transcended disciplinary boundaries, creating a legacy that influenced not only the ancient world, but also the Renaissance and modern science. Archimedes revolutionized mechanics and mathematics, providing tools that underpin engineering and physics. Eratosthenes advanced geography and mathematics, establishing methods for measuring and mapping the Earth. Hipparchus laid the foundation for observational astronomy and trigonometry, enabling a deeper understanding of celestial phenomena. Their achievements underscore the importance of curiosity, observation, and mathematical reasoning in advancing human knowledge. By combining theoretical insights with practical applications, these scientists not only solved the mysteries of their time, but also inspired future generations to explore the natural world.